Well,
So,
without further ado, mate, let's get into the 2025 NCC big changes to stop leaks by none
yeah,
other
man.
than Ross Taylor Associates. So,
Okay, cool, man. Okay, thanks very much, Byron, and thanks for the opportunity once again. All right, team, let's get into it. So, we're going to have some questions at the end, but very simply, three things we're going to cover: the problem, why buildings leak, and the solution. Real simple, yeah? So, let's have a look at next one. So, what's the nature of the problem? Now, I'm aware that we've got a mix of different people in the room today, in the podcast room. Some may not be aware of the scale of the problem, so let's have a crack at that. We've got a couple there that are remedial engineers, I see, who know all about it. But this one, and I think that's a video, we can start that up. Uh, what we've got is a huge amount of cost, time, and inconvenience for building users, particularly class 2, as in high-rise residential. And the thing about that is that when somebody makes a problem with one unit, the whole block, then 300 units have a problem. And this was a client of mine. He filmed it himself. He's standing in the puddle, and incredibly, the water is pouring in from the outside through the electrical fittings. Now, he went through hell. He went through 3 different consultants to try and solve the problem next. And he was just out of his mind when he came to us. This is a block of units in Sydney. That's the amount of time that this lady had these bags in place. They'd started to rot, and the bags are keeping out the water. That's the sort of damage that happened. Yeah. Now,
so
this is
this
not the...
particular, so let's break
Yes,
down
mate.
this defect a
Sure.
little bit, Ross.
Sure.
So, this is pretty much everywhere in Australia. Why do we see this, particularly in apartment buildings? Why is this such
Yep.
a common problem?
Okay, because the developer gets the job. Now, what he wants to do is to have the smallest possible floor-to-floor heights, so he can fit in that extra floor at the top to make money on that last floor.
Yeah.
That means he's got in this case, a 2.9 floor-to-floor height. So therefore, the slabs have got to be placed, and he doesn't know the BCA doesn't call for subsurface water, so he can have a flat slab.
Yeah.
A flat slab goes through. The window goes in. It might be a separate hob, same sort of thing. There's no room for the membrane to be turned up a proper turn-up height.
Yeah.
And the tiler comes through and he hasn't got any height to get falls. Yeah. So everybody, and at the end then, nobody's got any choice to change it. In that particular case of the one with the sandbags, it had no overflows, didn't have enough drainage. And that's in resi like this. I've just did a major review of the National Gallery. People would have heard National Gallery in Canberra, and we see that that's been leaking for 30 years as well. So it's not just blocks of flats. But we found that the roofs are 30% have 30% too little outlet drainage for the decks.
Yeah.
So we haven't been bringing the hydraulic engineers into discussion. So the overflows end up being like little piddly little things like this. Yeah.
Yeah.
We then get the membrane, which is about 0.5 millimeter thick, often the liquid membrane, because the developer's just gone for a cheap product and a cheap applicator, and so it goes on 0.5 millimeter thick. It's got no chance of withstanding the differential movement between slab and parapet, or between that and the sliding door. So it cracks. You get the leachate pouring out. And just so that for those that are wondering, oh, is it just resi? This is a hospital. This planter box, this box gutter had been blocked for years, so much so there were actually fish in this water, fish swimming around. Okay. So it's right across the board. Most of my works these days are major public buildings: Sydney Opera House, Parliament House in Canberra, Barangaroo, right through Barangaroo and so forth. So just in terms of context, we're talking about 2 to 9. It's not just high-rise resi is the issue. Okay. So then below grade, of course, 40 years ago when the BCA was written, car parks were above ground. They were the first floor, and then a 3-story walk-up. Or there was no car park at all because, 60 years ago, people didn't have cars or whatever. So the BCA that hasn't respected or seen the need for protecting below ground has generated leaks like these. Okay, and that's what we're changing. And so you end up with everybody doing their best to patch up and fix up and bodge up like this with another tube of sealant. Yeah. Or in fact, building in a bucket into the thing to fix the problem.
Or a stainless steel drip tray. That's a pretty good one too, isn't it, Ross?
Well, that we generally say that once you put a drip tray underneath is you've given up. You know, you're admitting defeat. And so just on that one before, just one back, in that case, what we've got is a proliferation of injection materials and goo and sealants and things to fix stuff. Yeah. We've got more waterproofing products than ever, and we've got more leaks than ever. See a correlation? Yeah. So the days of relying on it to do all the work are over because it's too expensive.
Yeah.
This is the assessment, the economic impact statement we had to do or be a part of for the changes to the BCA. And we saw that it's a $4 billion a year expense. That's light. We reckon the cost to business is probably that again in terms of, you know, building companies, their management having to go to court and manage all these things and hire lawyers and all that
the
stuff.
associated
Yeah.
costs. Yeah. So
Yeah.
and once again, it's the distribution of liability. Where's it go? What is the actual cost of it? Then, you're thinking about the homeowner, all the psychological stresses. It's,
Yep.
the figures.
Well, the interesting thing is, having been in litigation and being an expert in court, so far, architects and engineers and project managers and developers in Australia have escaped scrutiny in court. And as the builder gets it in the neck, the subbie's gone long ago, so the builder cops it. That's not fair, right?
Yeah.
They have there obviously are things that they do wrong, but that's, as a general industry thing, that's what's been the case in the last 30 years. That's what's being changed. We've been helping advise the Building Commission in New South Wales, and Victoria's picked up on that, is to say, no, we've got to have the developers on the hook in the first place. We've got to get the architects to the top of the design table, back where they used to be, and make them accountable, but make sure that the building's design is fully complete before you start, instead of the developer just flicking it off to design and construct. Yeah. So that gets us to this point. Here's the coordination thing we talked about earlier. Why buildings leak? Here it is. It's all on the drawings. And we thought that it's going to be a drawing orientated crew tonight. I think it is, Byron, isn't it? Yeah.
Oh, it's a
most of our
collective mix.
participants.
Yeah. It's definitely a collective mix on here. Pretty good. And a lot of return attendees, which is tremendous. So we must be doing something right.
Okay, cool. What have they got? Nothing else to do on a Wednesday night? Is that it?
Mate, maybe it's my lovely bald head of wisdom.
Well, no, I think it could be your hairdo,
Ross.
Yeah, I think it's a reasonable guess that it's not your hairdo, mate. So there we go. Yeah. So what we start with let's take a typical job. It's all about the 90% of the leaks are on the drawings, and here's an example.
Yeah.
Architectural drawing. So the architect has got a membrane there with fall, and he's got this silly membrane going down the outside because that follows a diagram that's in AS 4654, which is a silly detail that nobody really does. But what they've got is a flat slab and an arrow saying fall, which isn't very helpful, right? So then we go next to the structural engineer for the same job, and he's got the same thing. He's got just a flat line, right? So where's the concrete going to come for that fall is the question. Yeah. And if you change an engineer's drawing in a job, you've got extra weight of concrete on a cantilevered bit, things go wrong.
Yeah.
Then the engineer helpfully says, okay, 200 thick slab there he's got, right? Which once again is 200 to 250. Is that about falls? We don't know. And then provide falls in concrete to hydraulic engineer's detail. That's great. Very helpful. Thank you. We go to the hydraulic engineer. All he's got is a rainwater outlet and some dotted lines leading to it. Yeah. Now, straight away, we look at that and say, there's lots of planes of fall there that the concrete has got to get. We did a podium recently, reviewed a design, and we saw the podium had 450 planes of fall in the podium, right? And guys they've got an hour to pour the concrete.
Yeah.
and they've got to get those planes. So that's another thing we're rationalizing, which is part of our BCA changes. So we go to that and say that hasn't got the answer yet of how to do the falls, really. And then, of course, the engineer says, just as an escape clause, says waterproofing and slab by others.
Yeah.
And that's the classic. As we say, there's this wonderful firm that we should have shares in called by others, because it seems to get all the work. So it's an abrogation of responsibility, push it down the line, and then you've got a thin membrane getting rolled on to fix the problems. Yeah. Look at the spoon drain in there, so forth, that dish drain that somebody's carved in it. It hasn't got the proper falls because it's not on the drawings. And then we go to this actual job from the drawings, this next one, and you've got yourself a lake. Yeah, that's a real job, and it's those drawings that we just reviewed, and
Yeah.
it ended up being that. Yeah. And of course, once that happens, we go to the next one and we see what happens to the membrane. It shrivels up and dies. Yeah. And then you're vulnerable. Next. This is a classic case, being a hospital, where we've got that's a planter box. They called me in because we do a lot of work with design reviews, but this is one that we hadn't done a design review on. So our first question is to ask, well, give us a look at the drawings. And that's one of the major things we see in the remedial area. People aren't asking for drawings enough.
Yeah.
When we look at the drawings, we then find that underneath that is a movement joint. They've tried to repair it 3 times. They've blamed the subby, the waterproofer. Poor bugger had to come back and try and fix the leak. But it's a movement joint in a planter box over an operating theatre, right? So we go to the next one, and you see that's when they then pulled it out. They find there's a movement joint under there, and then we ask from the drawings and say we need that information from the engineers. How much movement's going to happen in this joint?
Yeah.
So we then get that information from the engineer, and lo and behold, there's about 40 millimeters of movement expected in that over 10 years.
Yeah.
And you're going to have a 0.5 millimeter membrane bridge that? No chance.
With inadequate detailing to boot.
Now, by the way, that other work, if we go back to the planter box, in terms of technical, it all complies to BCA Volume 1 and AS 4654.
Yeah.
So everybody ticks the box. See, there's a lot of people, and I find it is a problem in the industry at the moment, is that you've got people that are going around just checking compliance of standards in BCA and calling that, quality control. No, it's far from it. Okay. Yeah. So then we see there's this sort of movement. That's in a site after only 6 months. That's the sort of movement on a building site in a podium joint.
Yeah.
Right. And it's, theoretically, it's got another 10 or 20 mil to go. And once again, we'll roll some goo on to try and fix it. All right. And we wonder why it doesn't work. Okay. Next. Another example, that's the drawing, architectural drawing. That beautiful diagram on the right there, or the words slope tiles to floor waste, but the architect's drawn it flat. You've got a separate concrete hob.
Slope tiles, that's an interesting one, isn't it?
Yeah, slope tiles. You got to get that tile, you're going to bend it. I don't know.
Or something pack it up with tile adhesive, which allows for greater subsurface water entrapment.
All that stuff. Then you go to the next one. You've got no conversation. Whoops, we skipped one, I think. No, that's the next one. Okay. So we go from there, and this is the actual that I came in on because there's a $5 million court case around it. Yeah. Every balcony has to be jackhammered up. And just stay with that one. We've got the water then is held in a tank. The membrane turns up to the outlet. You've got a blue board on a stud wall.
Yeah.
The differential movement of the hob from the concrete lets water underneath it. It goes over the top. It stores the water forever. Water can't get away. Next one. So we have subsurface water just sitting there against the drain, right? Flat slab all the way through. Developers saved money on having a nice flat slab. So we get extraordinary rot and deterioration in the building. Yeah. Next one. Or this one where we got 150 mil of deflection of the concrete in the first 2 years, cantilever. And there was multi-million-dollar repairs needed. And next. in our industry, we blame the tiler for not getting the falls right.
Mm.
Yeah. So we've got to get, it's much more. So that's this diagram, actually that diagram is good. You see, this is what we end up with in our industry when we have all of the components being done in isolation and there isn't an integration of the design
Yeah.
early enough in the process to be able to make the decisions and change the design detailing so that the parts work.
Mm.
It's the waterproofing idea of I'll leave it to the membrane, it'll do the job. And it's just crap. Never has worked and doesn't work now. It's a paradigm change that's what's needed. And I come from the waterproofing industry. I've been a part of it for many years.
Yeah.
It's a complete change in thinking, is nothing less than that, because it's not just tweaking it and making sure the membrane goes on twice as thick. Okay. And then when you're, again, a waterproofing contractor turns up into the job, how's he supposed to detail that pipe collar with an outlet next to it like that?
Yeah.
Yeah. Okay. So there's a good friend of mine, Professor Mark Mariziki. He's been doing lean contracting, a thing called lean, Lean. And he taught me this sometime 30 years ago. And it's all about what you hand over to the next trade and having the planning done so that trades are handing over a buildable, good circumstance for the next trade. And that last photo was one where they're not handing it over a decent thing
Well, then
to the next trade.
you look at that could have been controlled by the project manager or the site supervisor to say, well, we're not accepting that. That's not ready for the next stage of work, so that has to be fixed before the waterproofer rocks up.
Yep. But my experience is with most project managers on high-rise resi, they have no idea that that's a bad detail. They're
No,
not actually. Very often they're just so busy managing the money and the program and keeping everybody in check and the paperwork. They're not looking at these details.
no,
The old concept of a clerk of works, quite frankly, I think that's what should be brought back.
yeah,
And the clerk of works has seen all that and he says, no, you're not doing that here. Take it out. Pull that wall down,
yeah, yeah,
So personally, I think that's the missing element. And I know the Building Commission in New South Wales didn't believe in it, but I think that's the next step that should be done, actually. And then the poor bloody certifiers that come in and check, once a week aren't going to be hung with the inspections.
yeah,
So below grade, we talked about before, it's been ignored by the BCA largely. It's coming back, and we're going to talk about. There's BS 8102 is a fabulous, it's a very good standard, British standard on below grade water management, and our team, the commission, the community of the watershedding community of practice have been very active over the last 4 years in getting that adopted as an Australian standard. In the meantime, your viewers, your listeners can get a copy of BS 8102 and they will find it to be very powerful for below grade. Just
so
a quick point. Yes,
yes,
just a quick point here is just want to highlight to everybody, if anybody tells you, oh, we're above the water table, we're okay, that's rubbish. All right. It's basically bullshit.
yeah,
The VADOS zone is the zone above the water table, and we find there's more leaks from the VADOS zone than there is from the phreatic zone, being the zone below the water table, because people ignore it often. Yeah.
yeah,
The VADOS zone is where subsurface water comes down through the soil after a big storm and floods in. Yeah.
yeah.
Cool.
And is that the cause of this particular leak?
Yep. That's that one. Yeah. Water
So
table was a meter below the slab, and that's the water that comes in anyway.
interesting, we talk about BS 8102 in,
Yes.
so we're referring to it as a standard. In Europe, it's a code of practice. So what's the difference between a code of practice and a standard, Ross?
Yeah, sure. Well, the wording of the two are very often different. So, like in an Australian standard, there's a very specific wording where they have a big difference between saying something should happen, shall happen, could happen. Yeah.
Yeah,
And so that there's a very clear language around it. A code of practice can often be written without that in mind. And so the words are advisory words about good practice, for example. Here's how you can do it. Here's a checklist of things you should think of, which is much less prescriptive than a standard. Yeah. So it's still a useful document to then improve your knowledge and to have a checklist to do things by, but it doesn't have the same authority often. Yeah.
So transitioning it from a code of practice over in the UK, or and then bringing it over to here in Australia and calling it a
Yep.
standard, it is to give it a bit more mandated power.
Well, now here's the key point. I suppose, I'm sorry, I'll just enlarge a little bit on your question. To have it be mandated or to be a reference document into the BCA,
Yep.
it has to have that wording so that the BCA can be, it's very specific.
Yep.
This code of practice won't be a reference document. It's a bit like the standard on ceramic tile installation. Yeah, that's not a reference document because it's a more of a guide to installation of ceramic tile, and this is a guide as well. So it is a slightly different. It may be a standard, but it's a guide. My comments before more precisely was about it becoming a reference document under the BCA, which is a whole other level. Yeah, good. So what we end up with is with these flat slabs with some screed on the top. Yeah. Now the screed doesn't matter. Now in the remedial area, I know we've got a couple of remedial engineers in the room. Remedial is a whole other game. We are talking about new buildings. All right. And that's a different story for the other. We're talking about new buildings, and what the intention of the BCA changes is to change from a pattern of using tiles on mortar screed to pavers on support pad or timber decks on frames, so that we get falls in the main concrete. And we'll come to that in a little bit more explanation. But here is the start of the problem when we have so much of the thing being reliant on membrane and the level of tiles and so forth. So the starting point we find is really about the shape of concrete, the location of concrete, and the geometry of the slab. Now, what we have here is, let me see, it's got a meeting recording button at the top, obscuring my screen. Sorry, mate. A number at the top of the page. What's that number at the top of the page?
2700.
Right, 2700. Just a moment. Okay. So the point here is that the concept of water shedding before waterproofing is allowing for all these things, such as floor to floor height. Because we have a look here, we often come across buildings with only 3,000 or 3 meters, 3,000 mil floor to floor height. But look at the things you've got to fit in.
Yeah.
You've got the minimum floor to floor height as the ceiling height as per the apartment design guide. Then you add in the minimum slab thickness, a bit of tolerance for the fact that concrete isn't poured perfectly. You've then got an RL tolerance over the height of the building might shift because the buildings don't necessarily go in exactly the height. You've got flatness in concrete as per AS 3600, which allows for 6 mil over 600 mil. You then allow 50 mil for the floor falls, a step down in the slab from outside to inside. The floor tile and tile bed average about 50. A bit of falls tolerance because tile it's not easy to get that perfect. It's giving everybody a little bit of room, yeah. And then you allow some deflection, and you end up with a total of 3.125 meters.
Yeah.
And you've only got 3 meters to play with sometimes.
Yeah.
Where do you get it? Well, the concrete's going to be poured already, so you're going to get it in shrinking, reducing the tile bed, or just having it fall the wrong way.
Yep.
Okay, so that's how leaks are created, and my thesis is 90% of them are on the drawings right there. Okay, what are we going to do about it? How are we going for time there, Byron? We can't talk all night, can we?
We can't talk all night, but we've got about half an hour left in this.
Half an hour for me now? Okay, cool. Let's go for it. So let's go back in time and let's have a look at when we look at what the right approach might be, why don't we start back, and a good place to start with the Romans. They had a good way. They didn't have many membranes on the market there. They did have one or two, by the way, but not much. And they had to rely on gravity as the way of managing water. Yeah. And the classic for them is that the aqueducts we all know about only because so there's so many have survived.
Yeah.
But they had a grade of 1 in 4,000. And I regularly go into building sites and the builder says, 1 in 80 falls, how are we going to get that? We can't do that. That's asking too much.
Yeah.
Yeah. We haven't got the technology. What a load of rubbish. Yeah. So this is an aqueduct. They actually had a gradient. They had very simple devices which were able to give them, and they also had a few thousand, heavily motivated free labor
Yeah.
to create these things, because they couldn't have it too steep and it couldn't be too shallow. Otherwise, there'd be too much erosion on these things. They also have what still stands today as the biggest unreinforced concrete dome in the world, 2,000 years old. The Pantheon, extraordinary device. And of course, you've got Roman tiles, you've got just the elements that we know work are all about collecting, redirecting, and draining water. So that's when we thought, hey, we know how sarking works. We know how brick veneer walls work. Next one. The good old humble brick veneer wall works well as long as it's built, put in right.
Yeah.
And it's relying on gravity, and we're going to show that now. This is how it works. This is the complexity of a brick veneer wall. And what we want to do is to take the essence of this and put it into the flat bits. Yeah. So the facade collects the water, beats against it. Now, initially it redirects it downwards through gravity, but also it absorbs some water, goes in, but that can evaporate out. Evaporation is part of the new concept of drainage. Evaporation is part of drainage. And then a small portion of water, 5%, 2%, something, gets through mortar joints or cracks or something. It gets inside, and once again, gravity takes over, drops it down. The huge benefit of using gravity in this model is that gravity is working for you 24/7 without charge, yeah, without warranty. Whereas a membrane's got a 5-year warranty and it gives up. Is that right?
No,
Just
yeah.
back one.
Sorry,
Just back one. Then it goes down, collected by a flashing. It's redirected. So collect, redirect, and then a weep hole and it drains. Very simple. Works.
Very
So
simple.
what we've done in changing the BCA is we said, why don't we capture the essence of that and put it into words? And that's what we've done. Next. The thing about it is that it's not a new idea. That's 1975, a structural engineer drew that. And he's got a slab with falls, a step down at the sliding door, integral hob on the outside, all drawn in a way that the subbies can all understand.
Yeah.
Yeah. They can price it. So they're not going onto the job and have to do something they haven't priced. The builder has something he can watch and manage. He's even got on the drawing saying allow for 30mm movement. How good's that?
Yeah.
Yeah. Now that is those joints, we've changed that arrangement, but the whole point that we're saying here is this is not a bright new idea.
No.
In fact, it's a bright old idea.
Yep.
All right.
And it's just been so how we, to that point, Ross, and we sort of touched on this a little bit earlier, but in that essence, there, it feels like we've gone backwards as an industry. I
Well,
I do a
I
lot of
think,
training with
yep,
architects and so
yep,
forth, and they say
yep,
the amount of time we spend on waterproofing detailing or
yep,
understanding of waterproofing, I know you and I both
yep.
don't use the term, is minimal, less than a week in their whole qualification.
Yeah, just nothing. One way I'd put it is to say that as an industry in this particular area, we have forgotten more than we've learnt.
Yeah.
Yeah.
It's
Now,
the pedestal system.
pedestal system, but just to that broader point, since you've raised it,
Yeah.
I've got an FJ Cruiser. Love that car, right? A Toyota 4-wheel drive. I've driven it through Central Desert. Had it 12 years. It's never let me down once. Never leaked once. Hasn't broken down once.
Yeah.
So facade systems in buildings are incredibly reliable, like that. Incredibly reliable facade systems.
Yeah.
So there are industries that can get complexity right. Yeah. So it's not about complexity. It's something else. So even our own industry gets facades right. What we're saying now is we've got to get the flat bits right.
Yeah.
And that's what this is about. So pedestals, back to that, is the pedestal support pad simplicity. There's evaporation involved, there's collect, redirect, and drain. And if you do have a problem and a crack or something, you lift up 6 tiles instead of jackhammering the whole balcony. All right? Simplicity. Okay. This is the watershedding principle. It's drain system thinking rather than storing with a membrane. And it's building in layers of protection rather than just putting it all on one little layer to do all the work. Okay, that's the concept. And so now we put it into the BCA, and that's the starting point for our industry, whether right or wrong, but it is putting in the new pathway. Let's have a look at how that works. Firstly, the 2022 BCA was divided into 3 sections. That was silly because it just confused people. We brought it back to 2 sections, part F1, and instead of calling it surface water management and damp, so forth, it's called water management.
Yeah.
The reason is that we put a proposal to the building code board. When I read that as the document over years, there was 9 different words for water. And as a consultant in court, you got barristers saying, but Mr. Taylor, this is not surface water, this is rising damp. And therefore my builder is off the hook.
Yeah.
Yeah. So we just finished up saying, hey, why don't we call water, and let's just call it water management rather than the other terms. That's what this is. So managing rainwater impact, here's these first golden words in the performance requirement. And for the tradies in your room that don't get a chance to read the BCA or not been exposed to it, in the big book, performance requirements is the legal part, as in the bit you've got to, that's mandatory.
Yeah.
There's other parts that are suggestions, called the deemed to satisfies. It's a pretty strong suggestion, but they're just suggestions in this format. I think it's a silly format, but that's where it is. So we've got it in the performance requirement that water, including water on the surface of the allotment, that's about the building shape and size, that is collected by a building or associated site work, must be redirected to a drainage system. So this is ABCB speak for water, collect, redirect, and drain. Much more simply. And now we call water. All of those things now are defined, so we can just refer to it. The only thing that water isn't is it's not condensation, because that's in another section of the BCA. All right. Now, the exemptions before, it sort of had a wobbly exemption for below grade, basements. We've taken that out. But what we have said is that there are some cases in C here, the exemption is where an authority, like particularly in Melbourne, they'll have authorities not allow any pumping out, for example, and they just want to have a membrane.
Yeah.
So, but that's another factor.
So
unfortunately, yes, go ahead.
So in that instance where you've got, some councils not allowing you to discharge into the stormwater system for a basement design,
yep,
you would be required just to have like a type A style system where you're applying the membrane to the structure of the building, maybe a type A, type B, to catch the water and direct it to the ground without discharging it into a stormwater system.
Oh, not so much that, mate, is then if they don't allow a drainage at all, then, and it's below ground, you might not be able to pump it up to the surface at all. So you're relying a lot more on membranes to be the complete barrier.
Yeah.
So in that case, you'll have structure, you'll have barrier, as in the terminology of BS 8102.
Yeah.
But you won't have so much of the drainage thing. Now, what we find is that when this is explained to councils, and when we're doing some very sophisticated basement designs in Melbourne at the moment, where on this layered approach, we have the concrete cutting out a lot of the water entry. We then have a drainage layer above the concrete and then a working type slab on top of it. It means that we can allow that little bit of water that seeps through, we're capturing it before it gets in and hurts the lift or whatever. Yeah. So it's a different strategy. All right.
So I think we've got a couple of duplicated slides here, so we'll just
Yeah. So
carry on.
that was just talking about that's the classic trying to overcome the classic case. That back to that slide, Byron. Um, no, back to the ag drain. Yeah, the classic case is that there's not a lot of care and attention given to a basement. This is
Yeah,
a resi one, and it's just the waterproofing is done by a backhoe. Yeah, some black goo's put on the back of the blockwork, some
yeah.
aggregates chucked against it, ag line, been and done, wash your hands of it, leaks every time. So um, basements as an afterthought are over. Now basements are in. Okay. All right. So drainage and grading, a fundamental change is the flat bits, in other words, the roof, balcony, podium, got to have overflows, and it must have a structural substrate graded with a minimum fall of 180 in the plane of the substrate to suit the drainage system.
Yeah.
Now, simply, externally, no more flat concrete. Okay? We've got to have it in the structural concrete because membranes don't like to be put on a flat concrete and then have some mortar put on them. And I'd suggest they shouldn't be put on the top of screed either, if a screed is going to move differentially from the concrete and crack the membrane around the perimeter. Okay, so we want the membrane to be on the structural substrate.
And
We,
so, just to be clear, the
yep,
intention then would be with putting fall in the structural substrate and no
yes,
screed,
yes,
proprietary or non-proprietary, would be used.
that's right.
So,
And yep,
in
we've
the
got
instance,
one
yep,
exemption there, mate. One
yep.
exemption is when you've got cars or vehicles and things like on a podium that's going to be having vehicles on it. Yeah. But otherwise, that's correct.
And so, in the instance where a sectional repair or the concrete slab is inadequate,
Yes.
how do we go about fixing it?
Oh, in a remedial job?
In
Okay.
a brand new job that, it's not fit
Oh,
for purpose for, the application
okay.
of membrane, for example, what do we do?
Yep. Oh, you got grinders at 10 paces. Get those grinders out, baby. Yeah. Start making a fall the hard way.
So there
Yeah.
could be a lot more emphasis on the concreters to get this right.
Okay. So one contractor, Fred Buddy of mine, said, and he's been doing this for 10 or 12 years. So it's not a new thing. People are successfully getting this right.
Yep,
But what he's saying he spent $500,000 on regrinding and shaping concrete to get the falls right recently because the concreter didn't get the falls. Yep.
yep,
What he's doing on the next job is he's saying to the subby, tell you what, here it is, it's loud and clear, 180 falls, right? What I'm going to do is if you give me those 180 falls, I'm going to give you a $100,000 bonus at the end of the job.
yep,
He's just saved himself 400 grand in repairs. All right.
yep.
So there's different initiatives, but now we've got to get the concreters and the form workers to the table.
Well, and like you said, it's a paradigm shift. So,
Precisely.
dot D, a monolithic hob.
Absolutely essential. Don't bolt on something aluminium and fill it with, aluminium channel and fill it with mortar because that'll
Yeah,
just water straight in. So it's a 70 mil hob as a step down, preferably. It could be a hob, but not really. The intention is you have an outdoor floor. The indoor floor is nice and high,
yeah,
and then you step down, and then your falls happen from there. Okay.
yep.
Next,
Okay.
yeah,
And so, sorry. So we look
yep.
something like this.
So we've got that. So that's just giving the concept. Again, we're trying to, in lectures like this or discussions like this, it's about getting the concept across. Then you don't have to have an expert there telling you what to do every step of the way. It's about having a screen and a cavity and a drainage plane. And whether you're in the vertical or the horizontal or basement situation, always look to have screen, cavity, and drainage plane for collecting, redirecting, and draining the water.
Yep.
Simple. Yeah. Cavities work. They are your friend. So in terms of practicality, we got huge pushback from people like the National Master Builders Association. Unfortunately, we got pushback from HIA. Oh no, the builders can't do it. It's unreasonable, blah, blah. It is. It's doable. There's good builders have been doing it for years. Mirvac have been doing this for 40 years.
Yeah.
Multiplex are doing it throughout their jobs very well in many occasions. Builders like Mantina in Canberra are doing it all the time. So Belconnen Concrete in Canberra have been doing it for 15 years. This one's done by Belconnen Concrete. What we have is a single plane of fall. We got rid of all the multiple planes, a single plane to a perimeter gutter. Those skylight hobs are poured in one, and the perimeter parapet is poured in one integrally with the slab, one natty fall right across, and that was poured without a crack in that concrete. So a collaboration, a workshop with the engineer to manage the mix design, the placement of restraint, cracking steel, and so that thing is waterproof without, in our old terms, waterproof without putting a membrane on it.
Yep.
So then we put a membrane on for just in case of something happening, but it doesn't have to do all the hard work like we normally put it through. Okay. Now that then had a full garden put on it. It had a full rainforest put on it.
Yep.
Right. And the point is that if there is any problem, you can get straight in and find it if there is a one crack open up.
Yeah.
So, but it's gone very well. It's been down 3 years. Now, bringing structural engineers into the game. In the workshops I've been doing over the 20 years, the one person in the room that gets bored quickest is an engineer, because they think it's got nothing to do with them, and they switch off and they start looking at their phone. Then we start talking about responsibility and the important role of the structural engineer in joining the fun, and how we need to know where that movement and the cracking is going to be. And suddenly they re-engage in the conversation. To help them engage in the conversation is we've now got in part B1, the structural provisions, which is the bit the structural engineers were interested in. We now have that in B1D2 that we in design for actions, and they're action guys, the engineers, they love actions. They're designing for actions, and now they have to accommodate the expected 10-year deflection in the structural substrate to fit in with part F1 that we just looked at. How about that? So no longer does the engineer say, no, nothing to do with me.
Yep.
All right. Now back to F again. It's critical that we then have simple things. And once again, this is just old school stuff. The joints in the slab have got to be now at the ridges. That might have been in 2022. We might have snuck it in there already, perhaps, but they've got to be located on the ridge line or the high point of the structural substrate.
Yeah.
Pretty sensible stuff. And be protected by a hob either side, so it's out of the water. And make sure you don't put it through a planter box or through, wet area. A water feature in a hospital, we had a movement joint going under a water feature. Yeah. So the 10-year deflections we've got to allow for, so you don't get these situations again. And it's very simple. There's a diagram like this. They just push the button and take a typical floor plate of a class 2 resi like this. You have a look at all the green bits of the balconies, the bits that get wet. Next one. What we see is the we're going to come to the deflection thing. So in this one, we're talking about we've got to have a minimum 3.2 floor to floor height to be able to fit all these falls and things in. Yeah. And so we go from that to the next one. We go from that shape to this shape, right? So deflection is allowed for. We got the outlet at the lowest point. In this case, the deflection might be in the cantilever balcony down, but the outlet's at the end. Yeah. Mm-hmm. So we place the drains where the maximum deflection is going to be. It's not to say that we're stopping deflection. It's just allowing for the known deflection. Yeah. And then enough floor to floor height that enables you to fit it all in. All right. Next one. Next shot. There we go. So hanging formwork, there's some techniques to be learnt, but basically there's nothing radically new. Taking some care to get integral hobs and so forth in the structure. This has to be learnt. The good builders will understand it already. The less experienced will have to learn. And so we come to surface finishes, being pavers, timber decking, reconstituted, plastic one, fake timber. The surface finish of a balcony or similar part must be self-draining, so the water must run through it. Or you can have the tiles directly stuck to a membrane when you've got the falls in the structural slab.
Yeah.
So you have some very classy finishes. It means you have a horizontal look to the whole balcony, and you have a nice level transition from inside to outside with the water draining down through and not building up. And you've got a beautiful evaporation zone when it's not raining, then it gets to evaporate. Yeah, it works. And we've done the costings. It works out to be almost exactly the same as doing topping and screed and 2 membranes and waiting for it and putting the tiles on. It's about the same cost.
So,
all right,
with the pedestal system, when you're specifying or scoping this in particular projects,
yeah,
excuse me, are you also recommending a maintenance schedule for the removal to clear out debris?
I haven't thought of it, quite frankly, mate. We haven't got there, but yes, that's a very good idea.
Because I've attended a lot of site inspections under pedestals, which I think is a tremendous system.
Yep.
Then we go into the other area of design where we're talking landscape gardening, and they've built the beautiful gardens with large foliage that releasing a lot of debris that ends up
Yep.
landing underneath the either decking or tiling top upper level because there's the cavity there. And a lot of these areas aren't being maintained at all. And we know,
Yep.
the degradation of the growing medium, etc., can actually
Yep.
compromise the membrane system itself.
Yep. Okay. Well, I'd put it this way. We don't care about the people that aren't going to care about their buildings.
Yeah.
What we've built in with these design things, these simple initiatives, is that they are robust enough, and we assume that the building won't be maintained. Like the public buildings I'm dealing with, hospitals, schools, universities, there's no maintenance done on the exterior.
Yeah.
We have to have a built-in robustness, as in overflows and layers of protection, assuming that things are going to go wrong.
Yeah.
But the repercussion of that going wrong is not catastrophic.
No.
Right? When they put in plants and trees with overly aggressive roots and things, or whatever it is, what we do, actually, we're going to come to in a moment, is we do planters. We're trying to get rid of planter boxes as well, by the way. Planter boxes should be banned. Then you don't have root damage. So you see, we're building in a robustness that makes it less like, assume that people aren't going to do the maintenance. I don't know anybody that lifts up the pavers and cleans under them,
No,
Byron,
neither do I.
right? So we're assuming it's not going to happen,
Yeah.
but we've got overflows built into the new regs, so that something goes wrong and then it all floods, and then they can lift them up and then they can spend money fixing it. And
Yeah.
right, but that's their problem, not the builder's problem, not the architect's problem. Yeah.
Yeah.
But we're building in robustness in the fundamental design is an important part, assuming that there'll be no maintenance. All
Yeah.
right. Okay, so here we come to the heat map, if you like, which shows in red is a hogging upwards, or deflection upwards is hogging, and then sagging in blue. So you can get that from your engineer. Then you can see where the low points are going to be in the balcony, and then you get your hydraulic engineer to put the outlet in the low points in 10 years. Because we often come back to buildings 5 or 10 years later and we find the outlets at the high points.
Yeah.
All right. Okay. So for those itching to get that next beer or the next glass of wine, we're getting to the tail end of this, man. What we did, the watershedding community of practice have worked on the 4 years with this as well, is a technical specification for how to do balconies. That's what the end result is. And now we show them, and this is going to be adopted as a handbook in the building code by the ABCB, and it'll be a national handbook. What we've done deliberately is to restrict it to only 6 pages, use cartoons, and make it more interesting for anybody to read. That's the whole picture. We can go to the layers, next one. What we're saying is this is a layered approach.
Yep.
First thing is put the drains in first. The first things you should design, I like to say to architects, the first drawing should be the downpipes, and then build the building around the downpipes rather than the other way around.
Yeah.
So get the drainage arrangement with the hydraulic engineer first, see where the downpipes can be put, inboard, outboard, long branches, short branches. Can they fit into the slab thickness? All that jazz. Yeah. Next. Then we shape the concrete accordingly to the outlets. Where the fall's going to go, where's the step going to be, where's the hop going to be. All right. Next, we then put the membrane in only when all of those things are in place and your overflow has been planned. Yep. Next, then get the window system to fit, whether you're going to have it flush or not flush, sliding, not sliding, facade cavity and so forth coming up to meet it. Get the flashings right. Get the watershedding principles of collect, redirect and drain going from the vertical across this connection point to the horizontal. Okay, next. There's just another couple of examples in it of different orientations, like a double step that some prefer to do. Yep, next. And that's where we end up with the self-draining floor finish, compliant with the 2025 NCC. Okay. So when that happens, really the idea is that we have the teams on site are able to do their job with the design being fully thought through by the various teams. They don't have to do the thinking on the job. They just do their job. They don't have to do other people's thinking for them. Yeah.
Awesome.
Next.
Well, that's the end, Ross,
That's
for
our end.
what you were
Yeah.
sent to me. So we're going to have a bit
Cool,
of a
man.
Q&A. I appreciate that,
Cool.
Ross. So I'll stop sharing, and if you want
Cool.
to,
I'll have another sip of non-coffee. Yeah.
mate, you get amongst it. That's the advantage of doing online master classes. You can get on it if you want.
It's a
Because there's
beautiful
a
thing.
recording as well. So, but if you get to the
Yeah.
end and you can't remember what we discussed, you would be able to review it again the next day.
Well, the lovely thing is I'm down in Gerringong in a motel. How about that? Because I've got called down here. So we're coming to you live from the wonderful world of Gerringong. So there we go, mate.
So we've got a couple of questions in the chat. So if you don't want to come online and unmute yourself, you don't have to.
Yep.
But if you want to put your hand up to come online, I'm happy for you to do so and ask the question directly to Ross. But we've got a couple of questions in the chat. One from Chris: who is usually liable for these cases if the builder has built as per the plans and engineering and it fails?
Yeah. In New South Wales, we're talking about?
Uh,
Or anywhere?
we can say New South Wales and anywhere. Maybe two.
All right. What it's been over the years is that if it fails, the builder gets it in the neck because he's the low-hanging fruit for the lawyers.
Yep.
Right? And then he's got to try and drag in the engineer into a court case to get them to pay. With the New South Wales regulations and now going to Victoria, no, there is if he has built it according to the drawings, which an engineer or an architect has signed off, then the liability will go to the designer.
So under the DPP. So,
yep. That's the fairness we're trying to build into it. In my view, you shouldn't be having a builder having to design it on the run.
Yep.
He shouldn't have any design responsibility unless it's design and construct, and quite frankly, that's not such a good idea in my mind anyway.
Yep.
He should just, and the subby as well, he should just have, his job is to price it and do it according to the drawings. So the drawings have to be complete. And now the developer who didn't hire enough consultants or didn't pay enough to the architect to do it is on the hook if they haven't done enough contract documentation.
So Chris has typed in Victoria who would be liable.
Yep, I don't know the Victorian legislation, but they are aligning it to New South Wales, and it would be, if that's the case. And they're coming in, I think the new rules come in June, and developer and builder are on the hook for building execution and designers, and they're going to be retrospective 10 years, by the way. Yeah.
So my advice.
Here we go. Your advice, Byron.
From my humble opinion.
Is this legal advice, Byron? Yes.
It's advice from my level.
Yep.
You document what you do and how you do it
Yep.
so that you protect what you do.
Good point.
And if you do that and you so a couple of and this is what I try to do with the clients that I work with is to establish the cookie cutter approach. And you mentioned there's, particularly Mirvac on a couple of occasions. These same contractors, same details have been doing so for decades and they have very minimal issues.
Yes.
The closer you can get to a cookie cutter approach, whether you're from a builder's perspective or from a trade contractor's perspective, you say, this is
Yep.
how we operate. If you do
Yes.
not choose to engage us because we operate in this manner, that is okay with us, but we are protecting our integrity, our quality, our compliance. We understand what we're doing. We know how
Yep.
it's got to be done to
Yep.
achieve a successful outcome. We're
Yep.
going to build to win in the end. Greg,
Gotcha.
Greg's got his hand up from WA, mate. Oh, it's only 2 o'clock over there, isn't it, Greg? So you're still killing it, mate.
Well, it's close to wine time, I think.
Oh, mate, I don't think it needs to be a build to win masterclass for you to have a charty there. Greg, how are you, mate? Good to see you
Good.
again.
Ross, seems you've had a lot of experience engaging with architects. If I
Yes.
was going to
I
run
was
a,
married to one. I was married to one once, actually. There you go.
well, I studied it actually a bit. So,
Yeah.
um, if I was going to run a seminar, for example,
Yes.
for architects, what would be the best things to teach them or to make them understand what they should be
Oh,
doing?
cool. Tell me what animal in the jungle are what part tribe are you from in our wonderful industry, mate? Are you an architect or a builder? What are you?
Trying to be a bit of a consultant as
Oh,
far as
bit of a
waterproofing.
consultant. Oh,
And
that sounds dangerous. A bit of a consultant, eh?
yeah,
Okay.
and I get it. Well, basically, I get involved in a lot of building disputes. So,
Right, okay.
waterproofing
Got it.
is probably one of the biggest problems. And,
Yes.
I've
Yep.
learned a lot about it in the last, I don't know, 15 years. And
Yep.
I'm still learning a lot. But,
Yep.
I want to try and improve the knowledge of people in WA a bit more.
Okay, cool, man. So, look, what are you got to show them? Well, one of the things is just to read the words of the NCC 2025 Part F, and we've deliberately written it so that if you read the words, you know what it says, as opposed to, like we said before, you have to reread and reread these documents often to understand it. So just get to know those words and then have that discussion with them about what the words mean to them. Yes.
Yeah, in
Um,
WA, they don't
yeah.
seem to adopt the NCC for a few years after the eastern states. So,
Okay. Well, tell them to adopt it anyway. The other thing that in training we do have online courses in Construct New South Wales on these principles. We've got two video courses that you can hire, so you can look them up on the digital learning platform. And once again, they can do those, and you could maybe go in and have a look and do a tutorial with them with those courses in mind and the content, and look
so
at the
where,
whole concept of watershedding together.
yeah, so where do you find those courses?
It's on the Construct New South Wales digital learning platform.
Okay,
Okay.
something I've just picked up here.
Yes, mate.
I'm just going to
Yep.
read this out. Something was just sent to me. Australia's building and plumbing regulators are strengthening national collaboration with the building commissioners of Queensland, Victoria, New South Wales, and Western Australia coming together in Melbourne on 19th and 20th of Feb
Wow.
for their first Building Commissioners Summit. The
Wow.
key
Hey.
theme was the value of data and intelligence-driven approaches to regulation. This was complemented by a strong focus on mutual recognition register,
Yep.
highlighting the importance of robust system that
Yep.
ensures accurate and consistent mapping of qualifications and
Yep.
experience between jurisdictions, along with a shared commitment to continue this work through the QBCC hosted licensing Simopsum in May to explore pathways for updating the mutual recognition register. So,
Cool. Okay. All right. So
so
WA, you're not going to be left out in the cold there, guys.
you're not,
Yeah.
mate. Ross, Any
Yeah.
other questions? I think we're. I think
Oh,
you're
there's one
more.
on the screen now. I think there's one there that I'd like to answer. How does Ross feel about certifiers asking for a performance
Oh,
solution
yep.
for balconies with pedestals? Does the new NCC accommodate this? Yes, it does. How do I feel about it? It's such a shame, and it's causing a lot of trouble in New South Wales. Unfortunately, there's some consultants are spooking the certifiers into thinking they have to do a performance solution for balconies pedestals, and they don't. It's just about reading the words of the 4654. It does allow for balconies with pedestals. It's just an illustration there that makes it look like it's not the case, but the illustrations are not mandatory.
Yep.
Does that answer? That answers that.
Well, it does, and we will cover that in the balcony one when we come up in around 3 to 4 weeks' time.
There you go.
So, Ross, you're more than welcome to hang on.
We're up.
Sure, you're
Okay.
probably itching to get off because you've had a
I
big
don't know. Look,
day.
it's been good having a chat with you, mate, with you and a few close friends. I've
Awesome.
enjoyed it.
I
But
appreciate your time.
I will sign off, and I'll say farewell, and full marks to people for tuning in at 7 or 8 o'clock on the evening for extra knowledge. It's a credit to them as well.
And
So
we'll email out a couple of links to some of the courses that Ross was talking about, so you can have
yeah,
the opportunity to have a look at them. And more training is better for the industry. So I'm a big proponent
wonderful,
of it. And Ross, I look forward
cool.
to a good year ahead, mate.
Yeah, we're looking forward to it. We've got a few more gigs to do together, haven't we, of this nature?
We do.
Let's see how the message gets across, huh?